Hey guys, welcome back to this tutorial on Raspberry Pi and Arduino interfacing. In the previous tutorial, we discussed the RGB LEDs. As you can see here, I'm basically displaying the yellow color, which basically is the mixture of the red LED and the green LED inside this RGB package. Okay, now we are basically displaying that by calling the analogWrite function, and we are writing 255 to a PWM value, which means we basically sending a full duty cycle on. Right, that's 100% duty cycle, and the same 100% duty cycle 255 on the green LEDs, while turning off, right, or 0% duty cycle on the blue LED. So that basically means the blue LED is off. Right, now you can see that from here on the previous tutorial we demonstrated that you can mix the colors by obviously swapping and changing whichever color you want here. So right now we've got the orange, okay, yellow, which is the mixture of red and green as I've stated, but they both have the same intensity. Now if you want to increase the intensity of red, then you must decrease the intensity of green. So if I put the green, let's say I put green a 50, okay, I put a 50 on green and then I write it in, we're going to see that the color is going to be dominated by the red LED because the green is only 50, so the intensity is very low. If I increase it to 100, we'll see that the color is going to change slightly. So, but all of this, we are doing it manually. Now, in the previous tutorial, I stated that it is possible to create some sort of a random generator function here that you can generate this number randomly. And that basically means you can be changing these values or changing the color on your RGB LEDs randomly after every second or so by generating these PWM values. Okay, and equally so, we can write an Arduino, a Raspberry Pi application with our Python script. Okay, and in that script we can literally send commands. Okay, we can send command to the Arduino by telling it, well, we want a green color. Okay, then we send color green, we want red, blue, and so forth. And you can also write a function to basically send some random values to the Arduino. So all of that is possible by implementing the bidirectional or asynchronous communication between the two computers that we have in front of us here. Okay, now without any further ado, we're going to first start with the first application here. So the first application, we're going to just use the Arduino script here to configure it so that we can generate numbers randomly. Now, before we move forward, I'd like to cover our RGB with this PC cover. This is basically a bulb covers, okay, so that will just be helpful to diffuse the light, okay, so that we don't get this full brown bright LED. This way we can see the color that we are generating much better. So I'm just going to place that bulb cover there. All right, so we've got our PC cover and we can just turn off the light, right? So the color that we have here is the combination of red and green, and we can see it much better with the PC cover. Okay, so in the meantime, please just click the thumbs up button if you find this tutorial useful, and subscribe to CMTEQ channel. That will be highly appreciated. I really thank you for that. Now, the first thing I'd like to do here is to first create a variable. So I'm just going to come here and create an integer variable. So int, and then I'll just call it value, right? and we can just initialize that integer variable to be equal to 0, right? Then I'm basically going to come into this analog control function, and in this function here, so the first thing I'm going to assign the val, right? I'm going to assign it a value that will be generated by the random function. Okay, so we're just checking what we're going to do here. So random, then we want to generate numbers, okay, that will be ranging from 0 to 255. Okay, so when we generate a number from 0 to 255, then this value here, we can just pass it here. Okay, so we pass the value there. Okay, then we're going to repeat the same thing again. So this is really a typical way you can do this thing, and the next time you also can just pass it here, and you generate again another new value and you pass it here. Now this is just as simple as it can get. So every time you come into your analog control, you generate a random number that will be ranging between 0 to 255. That will be setting the PWM duty cycle. Then you pass that value here, you generate another one, you pass it there, you generate another one, and you pass it there. Now let's go ahead and just write this into the Arduino and see what we're going to get. Okay, there we go. And it seems like it is indeed generating, and we are generating a number every 1 second. Okay, we are generating a number every 1 second. If you want to make it generate a number fast enough, you can change this delay function, okay, to like 500 microseconds, so that will be half a second. So you will be generating a new color every half a second, and you can see that it is happening much faster, the color generation. But now this is very simplistic, but we can obviously improve this code by creating an array of variable. Okay, so I'm going to create an array here, and I'm going to initial this array to hold basically 3 values only. So I'm gonna have int, and let me call these array. So we're just going to say rand value, okay, and we initialize it to be equal to 3, the size of the array. Okay, then we come into our function here, and inside here we're going to create a for loop. Okay, and in the for loop we're going to generate 3 random numbers, and that's going to be stored in an array of variable, and then we're just going to pass them. So that's basically what we're going to do. So I'm going to say int I, right, int I equal to 0. Okay, I is less than 3, and then we're going to basically just increment I. Okay, then here we must then call the rand value, okay, that we've created. That's the array variable. So we're going to say rand val, then we pass I, the number I. Okay, so we then pass I, which is going to be the placeholder. So it's going to loop 3 times, and this is then going to be equal to the random function, and this is where we then pass our coordinate 255. Okay, so we are capped here. Now we know that we're going to run this loop 3 times, and it will generate numbers, and they're going to be stored on this array, on this placeholder that will go from 0, 1, and 2. Okay, then the next thing we have to do here is to basically, after generating the numbers, is to call the analogWrite function. So I'm just going to remove this like that. Then here, this is where we're going to then call our rand val, and then we're going to then pass the array number. Okay, so this is going to be rand val Okay, and the first value on the array, the first number is 0. Okay, and the second one is going to be 1, and the third one obviously is going to be 2, like that. Okay, so every time we run, we generate, we store them, and then we distribute them here. So this is much neater compared to what we did previously. Obviously they're both going to execute the same. Let's just load it in. Hopefully there's not going to be any errors, and we see if it's gonna work. Well, done uploading, and it is working. Right, so we are generating numbers randomly using our RGB LEDs and this basic Arduino script. So this is how you can play with these kind of things, and this is Christmas time, so you can use these applications and to create a nice Christmas light around the house and have the kids and enjoy and appreciate the work of embedded system. Okay, so the first application is done. So this is basically a random color generator. Now the next application we're going to see here is basically we're going to send commands. All right, we're going to send command from the Python script here to the Raspberry Pi. So basically we're going to just modify the script here and send command to the Arduino to either tell it to turn green, red, or blue. So this is basically very simple. The previous tutorial I've already demonstrated how to do that, so you can go ahead and try to apply that. And if you want to see how we're going to implement it here, just stick around. It's a very simple modification. So I'm going to leave this function running. I'm not going to change it. So I'm just going to create another function here, or let me rather comment out this analog control, and I will create a new function, and I'm going to say call it Raspberry control. Okay, so this is going to be the Raspberry control. So let me just implement it here, void Raspberry control, and I want to avoid typo, okay, because I always have so many typos. Raspberry control. Good. Okay, now in this function obviously we want to implement a serial communication. So this is going to be very simple.